All right, hi everybody. So as promised, I was going to finish the ice cube question, and I went back to my classroom to copy down where we had left off, and it was all erased, of course. I should say our classroom, and I hope you all enjoy this picture here of Arjun. Arjun, this is my picture of you. All right, so I think we did part A already, but just in case there's any thing unclear, I just did it again. We left off with Thomas telling us, offering to us the rate of change of the area of a face, A equals S squared, dA dt equals 2S ds dt. This is dA dt 2S because at the moment in time it's being asked for. I didn't write the question down again, but I believe it was asking for dA dt at the moment when V equals 40 millimeters cubed. And we had already found S, right, at that moment in time earlier. So I just inputted that here. And here I had a little bit of an algebra challenge for you. See, when I plug it all in here, who of you were able to simplify from here to here? Look at that. See? 2 times 2 times negative 2 is negative 8. Downstairs here we have this 2 is being squared, right? So there's the 4. There's a 3 here. But look at all this canceling. This is cube root of 5 times cube root of 5. There's 2 of them. See how this works, everyone? It's getting comfortable with just some, not even algebra, what is this? Just canceling, right? This is how we do work that looks like we would need a calculator without a calculator. It's actually quite easy, and we're going to get better at this. We will, even if it requires brute force on the part of your teacher. Part C was talking about the diagonal of the cube, and so what I first talked about here in class, I think Thomas said this, the diagonal of the cube is, from front top corner, if you will, to bottom back corner. I called that D. This length here is still S. This length here, right, that's S root 2, and you may have to remember 45, 45, 90 triangles. If we look at the base of the ice cube, this length is S, this length is S. That means this triangle down here has to be a 45, 45, 90. And a 45, 45, 90 has the ratio of sides S times S root 2. And S squared plus S root 2 squared equals D squared by the Pythagorean theorem. So here's what I've got here, okay? And this is me squaring and carefully squaring and then combining like terms and then taking the derivative with respect to time. Look at that. Okay, and again, this is asking for the rate of change in the diagonal of the cube at the moment when V equals 40 cubic millimeters. So I know what S is at that moment in time. I know what ds by dt is at that moment in time because I believe that was from part A, wasn't it? Yes, it was right there. But I need to find D at that moment in time. And what I did here was, look what I did. When V equals 40, we know S equals that. And when S equals that, D equals question mark. And all I did was I just kind of took this down here and I said, well, when S equals 2 times cube root of 5, right? I found D squared. And then a little bit of arithmetic again. Look at this. Be really careful, everyone. When I square root both sides, the square root will undo this being squared. That's why this, right, is right here. But I'm still square rooting 3, okay? So then D equals this. No, I cannot combine these two radicals. One is a cube root, one's a square root. But now I have found D at that moment in time. So now look what I did. 6 here, 6s ds dt, 6s ds dt equals 2d, right? Here's 2d dd dt. And so here's an algebra challenge for you. Who here can simplify to solve for dd by dt in the easiest way? Actually, this isn't even algebra because there's no variables, like there's no x's. Let's just, who can kind of divide, we're dividing this whole expression on both sides. Who can do that in a way that'll be the easiest? All right, I'm going to take the challenge with you, or you can stop me and see who wins. All right, I'm going to work over here first. Let's see. 6 and 3, 1 and 2. 2 cube root of 5 squared, 1, 2 cube root of 5, gone and gone. All right, and what I've got here on the left-hand side is, let's see, 2 times -2, right? Is that right? Yeah, -4 over 2 cube root of 5 equals, 2 times 2 is 4. 4 times square root of 3 times cube root of 5 dd by dt. All right, who can do it? Who can do it? I'm going to divide both sides. When I divide both sides, I'm going to get this divides out, and I'm going to get -1 over 2 times root 3 times the cube root of 5, all of that squared. Okay, equals dd by dt. Oh, I have to squeeze some units in here. The units here are millimeters per second. Look at that. Look at that. It's not even algebra. It's like, who here can divide numbers with the least amount of work? Dun, dun, dun. Okay, that's it. What I'm going to ask you to do now is go to the rest of the homework, which takes you through Packet C. And then you'll notice on the teacher page I said, do these problems in Packet C, and then watch the screencast where I do out the solution to 2 of the more juicy questions. And what you can do is just pause me here and just know that you paused at 6 minutes, 30 seconds. And then I'm going to go and talk through the 2 questions that I worked out that I think were the most juicy ones. So I'm going to start that now. So what I'd like you to do is pause me now, go ahead and do Packet C questions, and then come back and for these 2 worked out. Okay, so in my estimation, I think these 2 are probably the most juicy ones, number 7 in particular. Here it is, right here, okay. Particle moves along the curve, da-da-da-da, all right. What is the value of dy dt when y equals 2? So here's my setup. Dy dt equals what when y equals 2? And of course, this is my known rate right here. And I made a note to myself, when y equals 2, right, because y equals root x, when y equals 2, it's the same moment when x equals 4, okay? So here, y equals root x is the relationship between y and x. I mean, it's traveling on this curve, right? I took the derivative with respect to time here, follow me right here, dy dt equals 1/2 x to the negative 1/2 dx dt. I'm now going to input in the moment in time information. I know dx dt is 4, x is 4 at this moment. The question is, what is dy dt? And let's not mess this up. 4 to the negative 1/2 is 1 over 4 to the 1/2. 2 times 2 in the denominator, 4 in the numerator becomes 1 unit per second. Part B. B says, how fast is the distance from the particle to the origin changing? Again, at that same moment in time. It's interesting again. Well, what I did here is I drew this red line, and I drew this red line, and I said I'm going to call that length d, okay? That way I can frame my question and say d by dt equals what when y equals 2, or when x equals 4, okay? And the question is, goodness gracious, how do I get an equation that relates d with the other variables, x and y? And yes, you see here x squared plus y squared equals d squared. I actually got there by way of the distance formula, okay? So d squared equals x squared plus y squared. Actually, it's really interesting. I did this one way, and I could have done it another way, but you could have also gone this way, like d squared equals x squared plus y squared. And I'll show you it gets the same thing. What I did here, d squared equals x squared plus y squared. Wait a minute, how did I get that? Let me see. Plus y squared. Oh, right. D squared equals x squared plus y squared. Oh, I see what I did. See how this plus sign, that plus became a minus for some reason. But what I did here, oh, no wonder. These are all going to be off then. Okay, so I have to change all these. Okay, so what I did here was, which I didn't do here, now that I'm catching it, I could, since I know that x and y are related, I could plug in, right, y squared, since y is root x, y squared is just x. So whether I use this equation or this equation and differentiate with respect to time, it doesn't matter one whit. But I'll just go here to 2d dd by dt equals 2x dx by dt plus 2y dy by dt. And I imagine most of you probably went this way. And right away, I'm going to just divide everything out by 2 so I can not deal with it. When at the moment in time that I care about is when y equals 2, x equals 4, dx dt is 4, is that right? I forget, what was it? Dx dt is 4, dy dt is 1. So I have d times dd by dt equals 4 times 4 plus 2 times 1. The question, though, is I need d. Here's me saying, like, you know, we need to find what d is at that moment in time. We need d when y equals 2. And I said, well, when y equals 2 and x equals 4, d equals radical 20. So what we have here is radical 20 times dd by dt equals 18. Okay? And when I then divide by radical 20, I get dd by dt equals 18 over root 20, which equals 7 over, oh no, I don't have that. I get, why do my answers not match up? I don't know why. I don't know why. Maybe you will find the mistake that I made for me. It's a minor one, right? Major, it's mega minor. And you know what? The thing is, like, these things are just proof again that those minor mistakes happen, right? And as long as we keep the minor mistakes to a minimum, they never really catastrophically impact us. It's if we keep doing them all over the place. Okay, I'll go find my arithmetic error here, but the important part is the setting up the related rate, or recognizing what the related rate was. All right, part C, what is the value of d theta by dt when y equals 2? Well, here it's over here. Let's look over here with me. This one was a great one. This one's a little bit juicy. D theta dt equals what, right? When y equals 2. And I just made a note here. When y equals 2 is the same moment when x equals 4 and when d equals radical 20. And if I'm looking at d theta by dt, I need to somehow introduce another dependent variable into this situation. And what I notice here is tangent of theta equals y over x. Tangent of theta equals opposite over adjacent. So tan theta equals y over x. Here is my variable equation. I'm taking the derivative with respect to time, and generally speaking, if I have a choice between a quotient rule and a product rule, I'm always going to go product rule. You know, quotient rule tends to be a little bit messier algebraically. So what I did here, as you can see, is I multiplied both sides by x, and then I took d by dt. Here is d by dt. Look at that. Okay? This part of it here is x untouched times d by dt of tan theta. D by dt of tan theta is secant squared theta d theta by dt. And then we've got all the information we need. We know what dx dt is at the moment in time. It's 4. But what is tan theta at that moment in time? Well, let's see. At the moment in time when y equals 2 and x equals 4, this distance is 2 and x equals 4. So at that moment in time, what is tan theta equal to? Opposite over adjacent. At that moment in time, tan theta equals 1/2. Look at that. Plus x is 4 at the moment in time. Oh, what's secant of this angle at that moment in time? Let's come over here. Well, secant is the reciprocal of cos. So cosine is adjacent over hypotenuse, so secant is going to be hypotenuse over adjacent. And we already said that at that moment in time, d is radical 20, which means secant of theta is radical 20 over 4, but we're squaring it. So that secant of theta squared at the moment in time is that. And of course, here's our unknown rate, and we know what dy dt is. Dy dt was 1. Where'd that come from? Follow a little ant trail with me. Come over here. Oh, it was from part A. Look at that. It was from part A. We're going to use it. And then when I do all the simplifying, look at how nicely this works out. I love these. I just love when the numbers work out so beautifully, right? I'm not going to be intimidated. Who's intimidated? I'm not. Look what happens here. This is pretty fun. radical 20 over 4 squared becomes 20 over 4 because one of the 4's cancels with this 4. You're left with just 1 4. And negative 1/5 radians per second is my final result. So that was a pretty juicy one. I like that a lot. Okay, the other one was this one. The car approaching was a multiple choice. A car is approaching. Maybe this one isn't that. Maybe it's not so juicy. Maybe you probably figured it out. But a car is approaching a right-angled intersection from the north at 70 miles per hour, and a truck is traveling to the east. Okay, blah 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 blah. Most important thing here is the drawing you draw. Look at that. You want to see my car? Here's my car. Want to see my truck? There's my truck. The car is coming towards the intersection this way. The truck is going away from the intersection. So this distance that I called C, right? This distance that I call C, C is decreasing. That's why dc by dt is negative 70 miles per hour. M, though, is increasing this distance because the truck is driving away from the intersection. So dm by dt is positive. It is positive. So I have the length C, I have the length M, and D is the distance between them. So the question here is saying dd by dt equals what when M equals 1.5, when C equals 1.5 and M equals 2? What's the equation that relates C, M, and D? Right here. C squared plus M squared equals D squared. I took the derivative with respect to time, right here, canceled the 2's out. Okay. Then I just started inputting. At the moment in time that we're being asked to find dd by dt, what is C equal to? What is dc by dt? What is M? What is dm by dt? Uh-oh, I need D at the moment when C equals 1.5 and M equals 2. And I guess where I left off. Oh, I didn't finish. Interesting. So 1.5 squared is 9/4 plus 4 square root of that equals D, all right? 1.5 is 3/2. 3/2 squared is 9/4. 2 squared is 4. And if I want to clean this up even more, because I do want to clean it up, this becomes the square root of, right? Multiply this by, what do we do, everyone here? Common denominator. I get 16 plus 9 is 25 over 4. I get 25 over 4, or 5/2 equals D. Oh, this is going to be so fun. So now I have, let's see, this equation becomes 3/2 times negative 70 plus 120 equals 5/2 times dd by dt. Let's do number sense challenge. Here we go. 2 into negative 70 is negative 35. 35 times 3 is what, 15? 105, is that right? Negative 105 plus 120. All of this times 2/5 will equals dd by dt. Look at that. So you can show off at a party, everyone. It's like, oh, look what I can do. I'm so fancy. And this becomes over here, negative 105 plus 120 is 15 times 2 all over 5. Boom, boom. 3 times 2 equals 6 equals dd by dt. 6, is it miles per hour? I think this question may have been multiple choice, and that should match up. Okay? Great job, everyone, and enjoy the long weekend. Hopefully you heeded my advice. I said this is a hefty homework assignment. Please pace yourself, and perhaps I'll do a couple of L'Hopital questions that you may have encountered in this packet C as well. Okay? Goodbye.